So, wala po tayong klase by that time. Kasi may klase din po ako ng masters. So, conflict siya sa schedule natin. So, unfortunately, I cannot meet you every Saturday. Sir, pwede ko po matake ng Saturday night? May I know your reason, Jan Clarence? You can just send a private message. Okay? Sir, module 1 lang po coverage ng exam? Yes po. Kung ano lang yung na-discuss natin, yun lang yung coverage. So, module 2 will start by next week. Okay? Sir, kailan po ulit ang exam po? Yung exam po natin is scheduled on Saturday. That is March 26, 10:30 a.m. to 12:30 p.m. And again, yung coverage is yung lahat ng diniscuss natin sa module 1. Okay? Okay, so it's already 10:35. I guess we can begin. Again, please prepare a pen and a paper because we'll have some problems to solve today. Okay? So, yeah, it's already 10:35. If you are ready to learn today, please type property to the chat box. Okay. Thank you so much for your responses. That's still our topic for today. No? Unfortunately, still fluid properties. No? Because we still have some no, that are left, which are the following. Surface tension, capillary rise, bulk modulus of elasticity, and compressibility. Okay? These are other fluid properties that describe the behavior of fluids. No? When we say fluids, it's both liquid and gas. So, that's what will be discussed today. Okay, this 4. So, let's begin with surface tension. Okay, so what is this fluid property? So, many experiments have shown that the surface of liquid behaves like a stretched membrane. It behaves like a stretched membrane. The material property that characterizes this behavior is surface tension, or it is represented by the symbol sigma. Okay, so it's just like stress, no? So pag sinabi nating stress, ang symbol niya is sigma. So same din with tension, okay? Surface tension. So, sigma yung gagamitin natin. And surface tension can be expressed in terms of force. So let us look at this equation. Surface tension is equal to the force along an interface over the length of the interface. Okay? So, what will be the unit of surface tension? The unit of force in SI is Newton, and the unit of length in SI is meter. So, An example of a unit of surface tension is Newton per meter. What about for English? For English, we have pound over foot. So that's the unit of surface tension. Okay? Or it can also be expressed in terms of energy. So the equation will become energy required to increase the surface area of the liquid over unit area. So for example, joule over meter square. That's surface tension in terms of energy. Now, for us to understand surface tension better, let us look at this figure. This figure shows us a water, okay, a fluid. No? This is water. This is the surface. Okay, this is the surface. So, the physical mechanism of a surface tension is based on cohesive force. What do we mean when we say cohesive? Sir, di daw po makapasok sa ligaw po. Okay, sige. Mamaya na lang, no? Miss Andrea, pag nag-check tayo ng attendance, refresh na lang, no? Yung mga persons na to na hindi nakapasok ngayon. No? So, going back, what is cohesion? When we say cohesive force, what is that? Can someone give a definition? What is cohesion? Thank you, Miss Raz. Thank you. It is attraction. It's sticking together. Sticking together of what? Sticking together of molecules. So this molecule is attracted to this molecule. Also attracted to this molecule. So they basically stick together. Okay? They have this cohesive force in between them, no? That makes these molecules stick together. Now, because molecules attract one another, molecules in the interior of a liquid are attracted equally in all directions. So we can see here, this molecule is attracted to this molecule, this molecule, to this molecule, to this molecule, to all of the molecules in its immediate surrounding. Okay? In contrast, we can look at the molecules at the surface. Okay? We can look at the molecules at the surface. They are pulled toward the center because they have no liquid molecules above them. Okay? So, this molecule is attracted to molecule, this molecule, and this molecule. They are pulled down. While the molecules in the middle portion of the liquid get attracted in all directions. Now, this is also the reason why a drop of water draws into a spherical shape. Okay. So, basically, the point is inside a spherical drop of water, there is pressure. Okay, there is pressure exerted by this cohesive force between the molecules. And that's what we're gonna solve. No, that's what we're gonna solve. Okay. So we'll have this example. In this example, we will derive a formula for pressure in relation to the uh, surface tension. So we will derive the formula. No, as well, we will also calculate the pressure. Okay, so that's the required in this problem. But for us to understand ano ba yung context, no? So basahin muna natin. So example 1, the pressure inside a water drop is higher than the pressure of the surroundings. Derive a formula for this pressure rise. Then calculate the pressure rise for a 2 millimeter diameter water drop. Use the surface tension 73 millinewton over meter. Okay, so let us solve this one. I will share my other camera. Okay, so let's answer this sample by first defining the situation. So let's understand the context. It says that the pressure inside a water drop is higher than the pressure of the surroundings. So it's helpful if we can first draw the figure. So let's say the water drop is in the form of a sphere. Okay, so this is the water drop. Now it says that the pressure inside is higher than the ambient pressure. So that's also the required, right? Kakalculate natin yung pressure rise. So that's the required. And we are given the diameter of this water drop. This is off, by the way. It's not or. So calculate the pressure rise of a 2 millimeter diameter water. So we have D, and this is equal to 0.002 meter. And then we are also given the surface tension. This is equal to 73. We have micronewton. Okay, micronewton. So meaning this is times 10 raised to 1. Okay, -6 according to Francis. Micro, no? Okay, if it's micro, it's -3. If it's mega, okay, it's times 10 raised to 6. If it's kilo, it's 10 raised to 3. So for micro, it's 10 raised to negative. This is Newton over meter. Okay, so basically we are set to solve this problem. So first we have to derive the formula. Okay, so we'll draw the FBT. So we'll cut this water drop into this section. So the free body diagram will look like this. So we have the force that's due to pressure acting in this portion of the water drop. And then this force will be counteracted by the force of the surface tension. Okay. Now, if we will use the summation of forces along horizontal equal to 0, then the equation will be force due to pressure is equal to force due to tension. So F sub P equals F sub sigma. Now remember, in the equation that we discussed earlier, surface tension is equal to force over length. Therefore, force force due to tension is equal to sigma times the length. We can substitute it here. So this will become F sub P equals sigma L. But what is L? Since this is a sphere, this L will represent the circumference. Therefore, this L is equal to pi d or 2 pi r. Okay? So this is now our equation. Now, F sub P, or the force due to pressure, is equal to the pressure times the area. Okay? Because pressure is equal to force over area. So, cross multiplying this to this, P sub I is F sub P is equal to P sub I times A. But what is A? Since this is a sphere, the if you will look at this section, we will see a circle. So we need to get the area of this circle. That's the cross-sectional figure. Therefore, this F sub P will be equal to P sub I times pi d squared over 4. So this equation is the area of a circle, which is the cross-sectional area of this spherical water drop. Now, the equation will become P sub I times pi d squared over 4 equals surface tension times pi d. If we substitute this equation to this equation. Now, if we rearrange, if we simplify this equation, it will become P sub I equals 4 sigma over E. Because pi will cancel out, D will cancel on this side, 4 will be cross multiplied to this side, so it will become 4 sigma, and then this D will be cross multiplied to the denominator of this side. It will become this. So this class is the equation that is used to compute for the internal pressure of the liquid. Okay? If we are given the surface tension and the diameter, then we can solve for this P sub I. Now, we are given those two. In this case, 73 times 10 raised to negative 3 Newton per meter and 0.002 meter respectively. So we can solve for P sub I. Okay. So P sub I is equal to 4 times 73 times 10 raised to negative 3 Newton per meter over 0.002 meter. Now, can you solve using your calculator? What's the answer? Thanks, Mark and Login. It's equal to 146. Anong unit? Newton per meter squared, right? Or this is also 146 pascals. They basically the same. No? When we say Newton per meter squared, it's equal to Pascal. This is our answer, 146 Pascal. Any questions with example 1? Sir, palagi po bang ito yung equation natin? P sub I equals 4 times sigma over D? Yes po. Ito yung equation natin. So, dinerive lang natin dito. But in your board exam or in your quizzes or exam here, you can just remember this formula. Okay, so para hindi na tayo mag-derive. Direct sub na lang. So, ito lang yon. Direct sub these two. And we will get the internal pressure. But if you're given the internal pressure naman, saka yung diameter, you can get the surface tension, okay, by cross-multiplying the diameter on this side and then dividing this by 4. So, this is the formula to remember. Okay. So let's test. Let's see if the concept was understood. Kindly answer this in a piece of paper. A small drop of water at, okay. So parang may kulang siya. This is 80 degree Fahrenheit. Okay. So a small drop of water at 80 degree Fahrenheit is in contact with the air and has diameter of 0.03 inch. If the pressure within the droplet is 0.093 psi greater than the atmosphere, what is the value of the surface tension? So in this case, the required is the surface tension. Okay, so please answer this in a piece of paper. And once that you are done, please take a photo and send that to our group chat. Then afterwards, we will check or we will answer this question to see if you are correct. Okay, so kindly answer this one first. If tapos na po tayo, paki-send lang sa GC. Please answer everyone, no? If you have any questions, feel free to ask them in the chat box. O kaya you can open your mic. Okay, yung pi d squared over 4, area siya ng circle. Okay, so si Mr. Lawrence may sagot na, as well as Mr. Vince, Patrick. Last 1 minute. Okay, so it's already 11:08. Let's answer this one. So, maraming salamat dun sa mga nag-send ng sagot nila. So, sagot na natin. Okay. So, sabi, small drop of water at 80 degrees Fahrenheit is in contact with the air and has diameter of 0.03 inch. So let's write the given diameter 0.03 inch. If the pressure within the droplet is 0.090 psi greater than the atmosphere, so basically we have P sub I equals 0.09p. This is pound per inch squared. What is the value of the surface tension? So the required is sigma. Let's solve. The formula that we derived earlier is P sub I equals 4 sigma over D. We already have the P sub I and the diameter, so we just have to direct substitute them to this equation. So we have 0.093 pound per inch squared equals 4 times sigma over 0.03 inch. Cancel yung inch. The surface tension will be equal to what? Okay. 0.0000698 pound per inch. So some of you converted the unit to pound over inch or pound over foot rather. So pwede din. Ganun yung unit natin. Wala naman naka-indicate. So solve nga natin kung ano yung value if converted to pound per foot. So 12 inches is equal to 1 foot. So times 12 ito. Ano po yung surface tension natin? So 8.37 times 10 raised to negative 3 pound over foot. So I'll accept both answers. So I guess majority or lahat is nakatama. So very good class. So these are the answers. Okay? Be careful na lang with the unit. Kasi in this case, naka-English siya. No? So, hindi siya Newton per meter. Pound per inch. O kaya pound per foot yung unit natin. Now, if hindi sinabi sa problem, wag na nating i-convert from English to SI. Kung wala namang sinabi, convert to Newton per meter. Wag na po nating i-convert. Okay? Just leave it be na naka-English. Kasi mahirapan tayo mag-check niyan. No? So kung hindi naman indicated, wag na nating i-convert. Medyo di po kabisado yung equivalent unit po. Sir, paano naging 6.98? Alin? Yung 6.98 times 10 raised to negative 4? Yun ba, Emmanuel? Ayun. So, thanks, Andrea. Okay. So, tapos multiply mo to, tapos divide mo yung 4. Makuha mo to. As simple as that, no? So, yun. Thank you, Andrea. So, gets na ni Mr. Emmanuel. Sige. Let's continue. So, we still have 2 or 3 rather na properties to discuss. So, punta na tayo dito sa capillary action. So, when we say capillary action, it describes the tendency of a liquid to rise in narrow tubes or to be drawn into small openings. When a capillary tube like this one is placed into a container of water, the water rises up to the tube because the adhesive force between the water and the glass pulls the water up the tube. So, may nangyayaring adhesive force in between dun sa glass tsaka dun sa fluid, which is water in this case. So, kaya umaangat yung tubig papunta dun sa tube. And this is called capillary rise. Okay? Now, this is the case when we have water and glass. Nagra-rise yung tubig. But if we have a mercury and glass, the reverse happens. In this case, the mercury will move downward because it has a different density, no, in comparison to water. Yung water kasi light lang. Yung mercury, based from the specific gravity that we discussed in the last meetings, 13.6. So, yung density or yung unit weight ni mercury mataas. So, mabigat siya. Ang tendency, mag-fall siya or mag-move downward. So, kapag naglagay tayo ng glass dito, no, narrow glass, ganun yung mangyayari. And this is called capillary repulsion. Okay? So, that's capillary action, no, basically. Now, what we want is to derive the equation for capillary rise. Okay? This is the parameter that we want to get, no, yung capillary rise. Now, paano ba natin makukuha yung capillary rise equation? Based from this figure, so we have a system. Meron tayong container na puno ng tubig up to this point. Now, because we put this narrow tube glass dito sa middle, and ang tendency is umangat yung tubig because of the adhesive forces between the two, the water and the glass. Now, yung capillary rise po is itong delta H. Yan, itong delta H. Capillary rise. So, paano ba natin makukuha yung delta H? Gagamit tayo ng equilibrium equation. Okay? Equilibrium equation In particular, yung summation of forces vertical equal to 0. Okay? So, we will have this FBD. We will have this FBD on the negative y-axis. We will have the weight, no? Yung bigat nung tubig. And on the positive y-axis, we will have the force of the capillary. No? So, this will become the weight equals surface tension force. Right? So, this is the summation of force vertical equal to 0. So, weight equals surface tension force. Now, di ba yung surface tension force equal siya sa surface tension times L? Now, yung L, nirepresent siya natin as pi d, right? So, this is pi d. And then we retain the gamma. Now, if merong theta dito, so we will have cos theta. Okay? So, that's the equation for the surface tension force. And for the weight, okay, for the weight, so we have this gamma times pi d squared over 4 times the capillary rise. Now, saan ba nanggaling ito? Well, ang ginawa lang dito is kinuha yung unit weight, no? So, kailangan natin yung unit weight ng fluid. So, unit weight ng water times yung volume. Okay? Yung volume nung tubig na to. Okay? So, paano ba makukuha yung volume? We can determine the volume by getting the area and multiply it by the height. So, ano ba yung area nung cylindrical na tube? So, cylinder siya. So, ibig sabihin, yung cross-section niya is circle. So, kaya ginamit natin yung area ng circle. Pi d squared over 4. And then we multiply the height. Okay? Delta H. So, ito yung volume, basically, ng tubig na yon. You know? Itong tubig na to. Eh, since yung unit weight is what? Kilonewton per meter cube. So, makakancel yung meter cube. Ang ma-retain is yung kilonewton. So, makukuha natin yung weight nung tubig. Okay? So, with that, so sulat natin, no? Sulat natin. Ano yung two equations natin? Well, for the weight, it is gamma times pi d squared over 4 times delta H. And this is equal to gamma, or sigma, sorry. Sigma times pi d cosine theta. Now, ang gusto nating malaman is yung capillary rise. So, this will be cross-multiplied to the denominator of this side. So, basically, Cancel yung D, yung pi, and this will become delta H equals sigma times 4, kasi cross multiply yun dito sa numerator, cos theta over what? We have the diameter times the unit weight. So, ito pala yung equation ng capillary rise. Any questions po? Sir, if may angle, always po ba dapat gamitin ay cosine? Yes, Andrea. If, magandang tanong yon, no? If the angle is 0, well, this is 1. Okay? Kung level lang yung fluid, so with the horizontal, so this will just be 1. Sir, ano po value ng gamma? Yung value ng gamma, Clarence, will depend on the fluid. So, kung yung fluid is water, then 9.81 kilonewton per meter cube for SI. But if the gamma is a mercury, then gagamit tayo nung gamma ng mercury. So, yung gamma naman, palagi siyang given sa problems. So, pwede na namin i-disregard yung cos if wala pong given na theta. Yes po. Pwede nyo siyang i-disregard. It means that naka-level horizontally si fluid. Okay? So, that's the formula, no, basically. So, any other question? Okay, wala. So, let's solve this example. Example 2. Calculate the capillary rise for water that is 20 degrees Celsius in a glass tube of diameter 1.6 millimeter. Use 0.0728 Newton per meter as the surface tension. Okay. So, yung delta H natin is 4 sigma over gamma D. This is cos theta. So, wala tayong given na theta. Ibig sabihin, we will disregard this. Okay? This will just be equal to 1. No? Meaning dyan, yung theta mo is 0. So, capillary rise is equal to what? 4 times 0.0728 Newton per meter over, so what's the value for the unit weight of water? 9,810 Newton meter squared. Or sorry, Newton per meter cube. Then we multiply this by the diameter. So we need to convert this to meter. So this will become 1.6 times 10 raised to negative p meter. Now, can you give the value of the capillary rise for the water. Okay, thank you. It's 0.019. Okay, pwede na yan. 0.019 meter. So, yun lang. No? Ano yung kailangan natin tandaan? Kailangan natin tandaan itong formula. Kailangan, alam din natin kahit papaano kung ano yung concept, di ba? Saan siya nanggaling. So, that's the answer. 0.019. Okay. So, for this one, tayo na lang yung magsagot. Hindi na natin siya papasagutan kasi it's already 11:30. So, sagutan na lang natin dito. Okay. So, question. Determine the distance h that a column of mercury in the tube will be depressed when the tube is inserted into the mercury at a room temperature of 68 degree Fahrenheit. Set D equal to 0.12 inch. May kasunod pa yan. Rho, okay, may given na rho mass density to be 26.3. This is slug per feet cube. Tapos gamma 31.9 times 10 raised to negative 3. This is pound per foot. These are the given. Now, we're looking for the capillary rise. Okay? We look at the figure. So, ito siya. No? Kasi yung mercury, ang tendency is to move downward nga because of its density. Whereas sa tubig, ang tendency is mag-rise. Diba? So, ang so-solve natin is ano yung H na yon. Okay? Ano yung H na yon? So, what's the formula? The formula is 4 sigma over gamma D cos theta. So, this will be 4 times 31.9 times 10 raised to negative 3 pound per foot. Over, we have mass density, no? 26.3 slug per feet cube. We can convert this to unit weight. So, paano ba tayo mag-convert from density to unit weight? We multiply the mass density by what? Okay. We multiply the mass density by the gravitational acceleration. In this case, it's English, so 32.2 feet per second squared. So this is 26.3 slug per feet cube times 32.2 feet per second squared. So yan na yung unit weight natin. Okay, ito. We have to multiply pa yung diameter. So ang given is 0.12 inch. Lahat ng unit natin so far is naka-feet. So we have to convert this. So 1 foot is equal to 12 inches. Ma-cancel yung inch, mapalitan ng feet. Kompleto na ba yung solution natin? Kompleto na po ba? Yes. Meron pa tayong angle. Okay. So, yung angle na i-consider natin is this angle. Because if we look at the derivation of the formula, here is the tube and here is your angle. So, it's derived using this a figure. So, we need to get the angle, no? The value of this angle. Okay? So, hindi ito yung kukunin. No? So, basically, that is cos 180 degrees minus 50. Because this angle is 180 and 180 minus 50 is what? 130. Okay? So, computing for the delta H, what is the answer in terms of foot? Okay. It's negative 9.69 times 10 raised to negative 3 foot, or if we will convert this to inch, we will multiply 12 to it. What will be the capillary rise? It's negative 0.116 inch. So actually, hindi siya capillary rise. No? Kasi bumaba no? Yung negative sign indicates that this height went downward. So kaya siya negative. Okay. So, this is the answer for example P. Actually, this is a problem that was given in the first PowerPoint that I gave you. So you can also check that, no, to You can also check the problems in that PowerPoint to supplement your learning. Okay. So, nagso-solve din tayo ng ibang problems para siyempre mas madami yung ma-practice natin. Okay, so let's go to the last two properties. We have bulk modulus of elasticity. What is this property of fluid? Well, yung fluid kasi, lahat sila are compressible. And to characterize compressibility, we use bulk modulus of elasticity. So, when we say compression, ang nangyayari or kapag kinocompress natin yung isang material, no? Whether it is gas, liquid, or solid, ang tendency is lumiit yung volume. Diba? Lumiit yung volume. So, this bulk modulus of elasticity will describe that scenario. No? So, in terms of the formula, paano ba siya i-compute? The bulk modulus is represented by E sub V o kaya E sub B. Sa ibang references, ito yung ginagamit. And it's equal to negative dP over dV over B. Or itong dP na to, this can also be represented by delta P over delta V over B. So, ibig sabihin ng delta, tsaka nung D, so this means differential, no? It means change in pressure. Okay, kapag dP. Kapag dV naman, so this is change in volume, and V is the original volume of the fluid. So, this dV over B, this is called the fractional change in volume. Okay? So, pag dinivide yung change in volume tsaka volume, makukuha natin yung percentage ng change nung volume. Okay? So, yan yung bulk modulus of elasticity. And then we have this another property which is very related to the bulk modulus of elasticity. So, compressibility. This is just the inverse of bulk modulus of elasticity. So to compute for compressibility, we have to divide 1 by the bulk modulus of elasticity. Now, this compressibility, this is represented by the symbol beta. Okay. It's equal to 1 over the bulk modulus of elasticity. And this is also called compression or coefficient of compressibility. It's the fractional change in the volume of fluid per unit change. So, it's compressibility. Now, let us answer this last problem. Sample 5. So, problem 5. A volume of 2 cubic meter of water is subjected to a pressure increase of 10 megapascal. Letter A, compute the change in its volume if the bulk modulus is 2000 megapascal. Letter B, compute the percentage of volume decreased. And letter C, compute the coefficient of compressibility. So, we can write the given. We are given the volume 2 cubic meter. Pressure increase or the delta P. So this is also yung dP, no, or differential in pressure, 10 megapascal. And then the required are your change in volume if the bulk modulus is 2000 MPa, percentage of volume decreased, and the coefficient of compressibility. Okay, so let's solve. Let's begin with the change in volume. So from the equation, E sub B is equal to negative delta P over delta V over B. So we are given the delta P, the V, and the bulk modulus of elasticity. So this is just a direct sub. No? So this is 2000 MPa equals negative 10 megapascal over delta V over 2 cubic meter. Ito yung hinahanap. Okay? We can cross multiply. It will become delta V equals negative 10 megapascal over, this is 2000 over 2. So it will become 1000 megapascal over meter cube. Now cancel yung megapascal, aangat yung meter cube sa numerator. What is the change in volume? Okay. It's negative 0.01 cubic meter. So negative kasi nag-decrease ng volume C water. Okay, kasi na-compress eh. Now, yung sunod na tanong is i-compute daw natin yung percentage of volume decrease. Kapag nakita natin to, ganito lang yung gagawin natin. So, di ba, nakuha natin yung change in volume. I-divide lang natin yun sa original volume. Okay? Para malaman natin yung percentage of volume decrease. We just have to multiply this by 100%. Okay? So, this is 0.01, yan yung delta V, over 2 times 100%. Ilang porsyento yung niliit nung tubig? It's 0.5%. Okay. Kahit disregard na natin negative dito eh. Kasi yung nakalagay naman sa question, percentage of volume decrease. So automatic, yung 5% yung 0.5% na yun, ibig sabihin nun, lumiit si volume ng water ng ganitong amount. So, no need to put negative sign. Okay. Last item, compute the coefficient of compressibility. So, this is just beta equals 1 over E sub B. O 1 over 2,000 megapascal. Ano po yung coefficient of compressibility? It's 5 times 10 raised to negative 4. This is what? Mm squared over Newton. Saan nanggaling yung mm squared over Newton? Yung MPa kasi equal siya sa Newton over mm squared. So, nabaliktad lang, no? Ito napunta sa numerator, ito napunta sa denominator. That's the coefficient of compressibility. That ends our discussion. Do you have any questions? Okay. So, may tanong si John Clarence. Sir, negative talaga yung pressure? Actually, ang negative doon is yung equation itself. Diba, E sub B equals negative delta P over delta B over B. Ang negative is C, bulk modulus of elasticity. So, lagi siyang negative kasi nga, compression, palagi nagdi-decrease yung volume ng isang object, in this case, yung liquid, because of pressure. Okay? May negative pala sir sa formula. Yan. So, kasama siya dun sa formula. Okay? Any other questions? So, hanggang dyan lang po yung prelim exam natin. Okay? Hanggang dyan lang. So, check lang natin saglit yung attendance. Okay, may tanong si Mr. Vince. Sir, solution-based po ba yung exam? Yes. Actually, we will have 2 parts. No? Dun sa mga na-under na sa akin, alam nyo na yung style. No? So, part 1, multiple choice, true or false. So, more on the concepts yung part 1. Siguro mga 5 items yon. And then, yung part 2 natin is problem solving. So, you need to write your complete solution and then you have to box the final answer. And then, i-upload nyo si solution, you will take a photo and that will serve as the answer for those items, no, under part 2. Sir, sa homework po ba, US liquid quart po yun? Okay, so, pwede natin i-check ngayon. Ilang items po exam, sir? 5 items para sa multiple choice, tsaka true or false. And then 4 items para sa problem solving. Sir, even hindi kasama sa PE ang Module 2, pwede po ba ma-publish 'to para ma-study na rin po namin? Okay, sige, sige. John Patrick. So, sige, i-publish natin yung Module 2. So, yan yung topic natin on Tuesday next week. Okay? Don't worry, kaya natin yung habulin, class. Kahit medyo mabagal tayo ngayon, kayang tapusin yan. Kailan po exam, sir? Sabado, Carl, 10:30 to 12:30. Sir, pa-share po ng solutions tsaka PowerPoint. Okay, sige po. Isa-send natin yan after the conference. Mr. Erwin Candido. Miss Cancilaw. Christine Joy. Siya ba yung di makakapasok? Josh Medvic Santos. Wala si Josh. Mr. Tasis. Parang andito siya kanina. Si Jerby. Pumasok, no? Nagloloko. Sige. I-excuse na lang natin. Si Erwin andito na. Thesis na wala ulit. Ah, okay. Sige, tas to answer your question, Andrea, anong item yun? Number 4 or number 6? Okay. For items 4 to 6, US quart yung gagamitin. Okay? US quart. Sige. Any other questions? Medyo nag-overextend tayo. Pasensya na, class. Talagang kulang na kulang yung 1 hour. Pasensya na kayo. So, ayan. Sige. Kita-kita na lang ulit tayo Tuesday next week. Again, wala po tayong pasok sa Saturday because may klase din po ako noon, no, sa masters. And yung prelim exam is scheduled on Saturday also. So, um, it will be open at exactly 10:30 a.m. up to 12:30 p.m. Now, if hindi kayo makapag-exam by that time, just send me a message now with your valid reason. Okay? And then yung assignment nyo for this week will be posted after this conference. And you can answer that homework until Tuesday next week. Okay? But I would highly suggest na sagutan na rin natin yon, homework na yon, because that will serve as a practice sa atin in preparation para dun sa prelim exam. Oh, yeah. Okay? That's our assessments for this week. Isang homework na due date Tuesday next week, ipapublish mamaya, and then yung prelim exam. Okay? Any other questions? If wala na po, see you on Tuesday and good luck sa exams nyo this week.